Hello, my name is Jason Sharp. I'm the president of Eye-Kraft Optical. We're a wholesale lab in St. Cloud, Minnesota. And today I want to talk a little bit about our newest digital lens design line, the Artisan series of digital lenses. Now, this is a presentation that I gave live a couple of weeks ago, and I had a lot of requests for a recorded version for folks who were unable to make the presentation. So here it is, the recorded version. And without further ado, I'm going to get into the design technology and the design elements behind the Artisan series and a little bit more information about the lenses. So with any digital lens product, the way manufacturers and design vendors present these lenses is they build a kind of a foundation or building blocks of technology for the lens. You know, with a free-form digital lens, we're really putting a design on a semi-finished single vision blank. So really, all of the performance of the lens itself comes in the digital design that we're cutting on the backside of the lens. And the Artisan lens series is no different. The Artisan lens is built on several market-leading design elements, and we're going to step through each one of these. Some of them are pretty ubiquitous with most digital product on the market, but there are a couple here that are really going to kind of change the game in digital lens processing, especially for Eye-Kraft and especially for our customers. So as we talk about digital lens technologies, we're building a foundation with our most basic technology, and then we're building quality and value as our technology tiers increase in complexity and performance. So we're going to start down here with all lenses that are going to contain the variable fitting height and variable inset technology, and we're going to progress all the way up to our top tier lens, which is going to contain the ergo path. And every step of the way, we're going to add more functionality and more capability. This presentation is designed to talk through each one of these design elements to kind of let folks understand what the lens is made out of and what it can do for you and your patients. So the first technology we're going to talk about today is the variable inset and minimum fit height. Most digital lenses allow for modifications to the fitting height and the corridor length and the inset. And this is the basic entry technology into the Artisan series and our DLS lenses as well. With a variable inset, the design allows us to move this inset up to 4 millimeters from center. So we can either converge directly below, or we can inset up to 4 millimeters out. And so if you have a patient that converges differently from eye to eye, or has vision only in one eye and converges straight down, we can personalize the inset for the patient in these progressive lenses. This is a pretty cool capability and allows us to get folks into premium progressives that may not have been able to wear them before. With the corridor lengths, customers who are used to DLS lenses are used to modifying corridor lengths for patients based on their frame height and frame shape. We can do that in the first two lenses in the series as well. So we can specify that corridor length and adjust it for patients. With the Artisan 3 and the Artisan Next, the top two lenses in the portfolio, we have a different technology called ergo path that is incorporated, and we'll talk about that in a little bit. Ergo path makes this process automatic. So the next technology we're going to talk about is digital profile. And digital profile is sort of the manifestation of our ability to move the progression and the design around on the lens to give the patient the best placement of the design and the decentration and layout possible. Digital profile promotes natural gaze motions and encourages comfortable posture for near and intermediate vision. So with a typical lens design, we enter the progression and slowly get into the full add power as we lower our gaze through the lens. With digital profile, we're going to achieve that full add power nearer as we travel through the intermediate into the near zone. And basically what that means is we can kind of shift our viewing zone for the intermediate and the near up in the lens and create a much more comfortable, easy transition and rotation of the eye. The benefits of digital profile include more area with 100% of the add power, an easy transition between the distance and the near, comfortable vision and posture while reading, and easier adaptation. You see in this graphic here, our reading position, kind of looking at this picture makes me want to turn my head up and down to try and adjust and get into my intermediate and my read. Here you can see that's much more comfortable and natural, and we don't sacrifice intermediate or distance vision with this technology. So Optimesh is the compensation technology for the artisan lenses. As most of you probably know, on the most current iterations of digital surfacing, a compensated prescription is given back from the lab after the lens is done. And that compensation basically is based on the patient's position of wear, and the characteristics of the frame and their physiology. We'll talk a little bit about how that compensation and why it's done. The patient sits in front of the phoropter, and the phoropter is at the same angle and has the same wrap characteristics and is at the same vertex distance for every single patient that sits down in the chair. It's basically a standard. When that patient takes his prescription, though, and puts it into a frame that he chooses off the board, that frame has specific characteristics, and the patient and how they wear that frame will differ for every single patient. And so what happens is with a digital compensation, we actually take those differences in each patient and we compensate that prescription from the phoropter to make the vision much better for that patient. There's a little video here that kind of explains the Artisan series compensation algorithm, which is called Optimesh.
Optimesh, precise optics in all directions of gaze. To provide precise and sharp vision, it is necessary to compensate the variation of the effective power of the lens due to the lens position. A controlled ray tracing technique calculates the optimum path for each ray, from its beginning at the object until it reaches the eye. The oblique astigmatism that appears in every particular lens position is neutralized. And, thanks to that, visual sharpness will become optimum in all directions of gaze. Breaking down the surface in a refined mesh, Optimesh technology calculates a virtual lens that is optimum for each position of use. Thanks to Optimesh, the final lens is personalized according to each user's particular vision requirements. Optimesh, precise optics in all directions of gaze.
So with Optimesh and with most digital compensation, as the patient is looking straight forward through the optical center of the lens, that ray path passes through the center and to the eye. But as the patient's gaze and their position of wear travels from the center to the periphery, more aberration and more astigmatism is induced. Optimesh and most digital compensation technologies will compensate and adjust those ray paths to mitigate that aberration as the patient gazes from the center to the periphery of the lens. So it really makes really crystal clear vision, less swim, and better performance from the center to the edge of the lens. So the benefits of Optimesh is we have wider lateral visual fields. We minimize our oblique aberrations. There's a wider and more comfortable viewing area and reading area, and they're easier to adapt. Customized and personalized lenses for each user typically don't come back because the experience between a digital progressive lens and a traditional progressive lens is just night and day. Even the least expensive digital product is basically far and above any traditional molded product, which is why a lot of traditional molded products are kind of on their way out the door right now. The next technology we're going to talk about is called binocular balance. So binocular balance basically balances the level of astigmatism on both sides of the corridor. And I like this graphic here because it lets me sort of talk through what happens when we create a progression in a lens. So the way the physics of light works basically is if we're going to modify the surface of this lens to direct light in a manner that we are choosing, what happens is we're going to create this astigmatism, this aberration at the periphery, no matter what we do, whether it's a traditional molded lens or a digital surface lens, that aberration is going to be in the lens. Right? And as we create a digital product, what happens is we want to take this modification that we've made in the near and we move it towards the nasal of the lens to create the required inset for the patient for their near PD and their convergence. And when we do that, what happens is this astigmatism sort of gets squished towards the nasal, and so we have a little bit more aberration at the nasal than we do at the temple. Well, with binocular balance, the technology takes this astigmatism and this aberration at the periphery and balances out a little bit more between the nasal and the temple. And this really kind of leads us into some of the top tier technologies in this lens that we'll talk about in just a moment. But basically, one of the great benefits of digital surfacing is that we know we're always going to create this aberration at the periphery, but now we can control where it's going to be and to what degree. And as we get in towards the clear view technology, which is sort of the key to the whole system, we'll see that we can do some other things with distortion that are pretty amazing. So binocular balance is we're balancing out the astigmatism from the near, from the distant, or from the nasal to the temple. So the benefits of binocular balance: we can achieve maximum comfort. We have both eyes working as a system comfortably with less distraction with that distortion at the nasal. The binocular vision is really nice. Being able to get into and feel the intermediate field and really transit that corridor and that channel a lot easier is there. We've got great distance and great vision in all distances. The lateral images merge easier and better. And near vision has a marked improvement as well with binocular balance. As I just mentioned, clear view technology is how this lens sort of differentiates itself from pretty much anything else on the market right now. And this is what's pretty exciting about our top tier Artisan series lenses. So we talked a little bit about how we can manage the astigmatism and the lateral aberrations with binocular balance. Clearview is taking that concept to the next level. Clearview technology is groundbreaking, and it's an element that distributes that distortion and that aberration at the periphery using the frame shape and decentration. So with Clearview technology, what we can do is we take the shape of the frame and imagine a standard lens shape here. And this is a traditional, actually this is a cylinder map for a digitally surfaced lens. And we've surfaced this lens already, and now we have our frame shape that we're going to install right here in the center of the lens. And what happens is we've got all this astigmatism that we've cut on the uncut lens, and now we're just going to lay our frame shape on top of it. Well, what Clearview does is we can manipulate this aberration, right? So if our effective frame shape is here, right, we really don't need all of this additional add power down at the bottom of this lens. The design has said, hey, we're going to create our add power down here, but if we're just going to cut it off of the lens in finishing, we don't necessarily need this area to be optically performing. So what we do is we take this astigmatism and this distortion at the periphery that we have up here, and we're going to squash it down. We're going to squash it out, and we're going to push it out to the periphery of this uncut lens so that inside the performing lens, inside of the final lens itself, we've minimized this aberration all the way through. So this technology is really amazing. Lenses with clear view can have between 15% and 40% fewer aberrations than a typical progressive lens. What this means is we're creating a visual experience in a progressive that is approaching and almost near to normal natural vision through the lens. So some of the experiences that I've had with field tests on the Artisan Next, which is the flagship lens of the Artisan series. We'll talk about the rest of them later. But the Artisan Next, folks will put this lens on, and depending on their prescription, at first they don't really believe they're wearing a progressive lens. Especially with a lower correction, with a little bit less cylinder and astigmatism, the patients don't really notice any distortion in the lens itself, and so they don't believe they're wearing a progressive until we ask them to read. And once they understand that they have an actual add power in the lens, the results are pretty amazing. And so this technology, the Clearview technology, is what is going to set this lens apart from anything else out there right now. And in our area, the only place you can get this lens with this technology is at Eye-Kraft Optical. So the benefits of Clearview: it minimize aberrations up to 40%. There's unmatched visual fields in all zones. When I say unmatched, there is nothing that my customers right now can purchase from any lab that has this kind of performance. Any of the labs that are competing with me, with my customers, will not be able to match this performance, and I will say that right now. This lens is going to beat anything that you're using, and I will challenge my customers to try this lens with patients who are difficult fits, who don't even like the top tier lenses from branded multinational corporation labs. This lens is going to be their fit. They will love it. It's going to reduce motion and rolling effects. It's going to be just a nice, comfortable, clean experience for anybody who's wearing this lens. So one of the technologies that this design allows us to do, some of you are familiar with our lenticularization process that we use with the DLS series of digital lenses here. And lenticularization basically takes a plus or a minus power lens, and we remove some of the excess thickness in the surfacing process at the edge of the lens, at the periphery of the lens, to help make higher power prescriptions thinner and lighter. It opens up some opportunities with frame styling and design and lenses for patients who, because of their prescription, have never been able to do those types of things. And it's actually a really great technology. We've been able to fit progressives and digital single visions on patients with up to minus 22, 24, 25 power, total power in their lenses. Plus powers get thinned out, and it really reduces that kind of Coke bottle-y or fish-eyed look in lenses with high power. So lenticularization is great. Thin Max is a design for the Artisan series of lenses that's focused specifically on plus power patients. And what Thin Max does is, where lenticularization takes this job and shaves off the edges at the periphery, our frame shape is still somewhat within the diameter of this lenticularization. So what we run into is patients have great center thickness and edge thickness, and they have great visual performance in the center, but once we get out to the periphery of the frame, we hit this lenticularization, and this is not an optically performing zone out here, which for patients who are dealing with those types of powers in their lenses typically isn't a problem because their head turners are ready. But with Thin Max in the Artisan series, and this is available in the Artisan Next and the Artisan 3, what we do is this crib diameter is the diameter of the lens after we're done surfacing it. We take the shape of the frame and we take all this excess thickness that we're just going to cut off the lens when we finish it, and we shave it off out there, but we leave that visual performance in the shape of the frame. So what this does for us is it gives us a maximized edge thickness, right? And also maximized center thickness in plus power lenses without having to lose visual performance out at the periphery of the frame. So this technology is going to be really cool for your higher plus power patients to really get them into the highest performing product on the market right now in something that's also cosmetically the best thing they've ever worn. So cosmetics and optical design performance are maximized in these lenses. So this is a cosmetic wow for opticians and patients. You're going to see high plus power lenses come in with thicknesses that are just astounding for you, and your patients are going to be just wowed. They're going to be floored not only by how the lenses themselves look, but how they can see with them. We're guaranteeing minimum thickness in these plus powers. What we can do when we eliminate a lot of this thickness is we don't have to worry so much about you have to have a very small frame or a very large frame, and we have to limit materials. You know, there's only certain materials that we can do in 167 or 174, but if patients have a thin max, maybe we can look at doing things like extra-active polarized or dry wear, or things that typically might not be available for those patients. And just like all of these designs, you know, we're really fostering good posture and ergonomic comfort. You know, it's just kind of a whole physiology solution for neck and back and body and eye fatigue due to gaze posture. And it's the best visual experience on the market again, with the best cosmetics. So the final technology in the portfolio is called ErgoPath. And for folks who are familiar with our DLS digital surfacing line, DLS really relies on adjusting and managing corridor lengths to sort of customize individual patient experience, and it's actually really nice. You know, we can kind of create softer or harder designs for patients based on, you know, their wear history and their wear, you know, their position of wear and the depth and seg height of their prescription in the frame that they've chosen. And this has been really nice for that lens series, because basically we can customize this something for every patient. But the limitations of the DLS line is, you know, that corridor length is given and measured in a linear length, right? And it kind of does not take into account the actual gaze angle or the visual angle that the eye travels through the lens to get to the reading area. And this is a little bit limiting because on the DLS lens series, we kind of have to specify that corridor length. A lot of offices are successful in just shortening it up every time. A lot of offices specify a corridor length on every order based on the frame height and frame shape, but it can be a little bit clunky in prescribing and dispensing. Well, with ErgoPath and the Artisan Next lens, which is the top tier lens, what we're doing is we're automatically choosing the optimum corridor length based on the gaze angle of the eye traveling through the lens. So we are actually talking about eye rotation in the lens itself. So the vendor, the design vendor who has designed this lens, basically did a huge study, a massive study on population wear and what the most comfortable eye rotation angle was for all of those patients. And 85% of those patients fell within the 26 degree to 32 degree range, right? So what ErgoPath does is it takes that optimum angle for between 26 and 32 degrees and automatically calculates that ideal corridor based on the position of wear, the seg height of the design, and the prescribed lens. So we're creating automatically that corridor length based on the eye rotation and not on a linear measurement. Really what this does for us is we can kind of stop thinking about having to specify a corridor length or customize a corridor length for our patients, because it's done automatically with ErgoPath. So it's automatic optimized corridor selection. Ergonomics are optimized, and again, we're maximizing that comfortable posture. And it helps mitigate eye fatigue and muscle strain because we are allowing that eye to rotate through that just most comfortable eye rotation angle range. I'm going to talk a little bit about the lenses in the portfolio themselves and kind of how to position these lenses. So the way we've got these set up is we've got a good, better, best, and ultra premium product offering in the Artisan series, right? So the way the lab positions the lens will differ greatly from how the office or the optician or the retailer will position the lenses, just based on individual preferences, what your market is like, and how complex or simple you want your product offerings to be. So the standard or the good version of the lenses is the Artisan 1. The Artisan 1 is a non-compensated digital design that incorporates the benefits of digital profile, but does not have the other technologies incorporated into the lens. The Artisan 1 is a fantastic digital lens, and it will compete with and beat any traditional lens on the market. The lens compares with the DLS Everyday, which is the uncompensated DLS product, but it is a step above that lens because of the digital profile technology. There's a 14 millimeter minimum fitting height on this lens, and we can adjust that inset up to 4 millimeters, and those are standard throughout the rest of these lenses. The better version of the Artisan series is the Artisan 2. The Artisan 2 incorporates digital profile and OptiMesh, the compensation technologies. Now, we can't prescribe those position of wear measurements. However, the average position of wear is incorporated to help optimize that ray path in the frame based on the average position of wear. And so there will be a compensated RX that comes back on this lens. We don't have the clear view, binocular balance, ergopath, or thin max available in this lens, but it is a better lens than the Artisan 1. The premium or best version of the good, better, best profile is the Artisan 3. Now, the Artisan 3 incorporates digital profile, OptiMesh compensation. We have the clear view distortion mitigation technology in the Artisan 3, and we can cut a thin mix lens in your plus powers for your hyperopes in this product as well. But we are not incorporating the binocular balance and ergopath technology in this lens. This is a high performing, excellent lens for your patients. Now, the Artisan Next is our next generation flagship premium progressive lens. This lens incorporates digital profile, OptiMesh, clear view, binocular balance, and ergopath, and we can cut a thin max version of this lens in your plus powers as well. So all of the technologies we've talked about today are bundled into this next generation lens. This lens will stand up toe to toe and in fact beat any other digital progressive that you are using right now. A lot of times I will get questions. I'll kind of backtrack just a little bit. A lot of times I'll get questioned on some of these trainings that I do on digital designs about position of wear and compensation that happen in the OptiMesh technology. Do we have to take those measurements? And a lot of that is driven by the bad taste that folks have in their mouth on some of the equipment that was dropped in offices a few years ago that take all of these position of wear measurements, and a lot of times the measurements weren't accurate, the machines weren't calibrated properly. There was a tax bill associated and they weren't really free after all, and eventually they just broke down, and to replace and fix them, the bill was astronomical. Those types of things. With position of wear for our lenses, and this goes with DLS and with the Artisan series, you do not have to provide me those measurements. The average position of wear compensation that is done is really very accurate, and will compensate lenses to a high degree for patients, especially if they have an average position of wear. The only time that I really start to sort of consider adjusting those position of wear measurements is if the patient has an non-standard position of wear. So if they wear a lot of pandoscopic tilt in their frame because of the height of their ears or their preference for frame wear, if they have an extremely long nose and their vertex distance is non-standard, if they converge differently and we need to specify an inset for them, all of those types of things, if they are definitely non-standard and obviously that patient is going to have an experience that's a little bit different than the average patient, then we want to talk about maybe providing those measurements to maximize the experience for that patient. Now, one thing I will say is if you have a wrap frame, if we're putting a digital progressive into a wrap frame, anything that's 6 base or higher, I would definitely recommend taking a wrap angle and sending that to the lab with a prescription. It's really going to make a huge difference for any digital product, basically. But for the Artisan and the DLS series from Eye-Kraft, that wrap angle will absolutely maximize the performance of that lens for those patients. And that wrap angle is really easy to take. We have our fitting charts for DLS and for Artisan. It's got a really easy wrap angle. You place the frame down on the fitting chart, take your wrap angle, and you send it in with the order, and it really will be the best solution for that patient. So this is our series of Artisan lenses, the Artisan 1, 2, 3, and next in the good, better, best, and next generation premium digital progressive lenses. Now, as time goes by this year, there are a few other options in the Artisan series that we're going to be releasing, including digital single vision, some task and occupational lenses. There's a driving lens that we'll be validating and releasing soon, and there is a curve or wrap lens that's designed specifically for those wrap lenses that we talked about that'll be available soon as well. I want to talk a little bit about the comparison between our lenses and our competitor lenses, and these are competitors that I've assigned random alphabetical designators to, but these are top tier branded lenses that are in the market right now that many of you may be familiar with. This is just a standard cylinder map that was taken on our Artisan Next lens, which is the flagship lens, and these competitors. And you can kind of see the difference here. So in this lens and the competitor lens, you can see that we've got aberration and cylinder manifesting in the actual distance portion of the lens. And we've got aberration that's getting extremely close to the fitting cross. So you can tell, as the patient's eye strays from the center of this lens anywhere in the distance, they're going to start running into aberration. You can see the channel is blocked up by cylinder and aberration, and in the near, we've got a ton of trash down here. There's a lot of garbage. If you look out, the density of the distortion at the nasal and the temple here are pretty pronounced. When we look at the Artisan Next lens, that density is dispersed quite well out here in the temple. And we even have a little bit less density and a less aberration in the nasal here. All of the trash that you see in the competitor lens down in the distance through the near through the channel in the distance is gone and mitigated. And the density up here towards the top is really mitigated as well. So we've got a nice edge-to-edge performing lens here, minimal distortion throughout the channel in the near, and it's really balanced out and blended nicely out at the periphery here. This is a great performing lens for your patients. And then finally, the next competitor that we'll talk about is another random designator. Look at all of this distortion in the cylinder up in the distance here. This is not an edge-to-edge performing lens. Got a lot of garbage down in the near area. The distortion at the periphery is also reduced in the next here. And you can see out at the nasal in this lens, we've got a lot more distortion density as well. A little bit less cylinder at the nasal here. But again, edge to edge in the distance, minimal distortion in the channel. The near is much clearer and with less distortion. Again, it's a much better performing lens. I want to thank everyone for taking time today to watch this video. I know you had to take about 35 minutes out of your day, and I know time is precious for you, and I really appreciate that. I'm going to go ahead and put my contact information for the lab up here real quick. You can get a hold of the lab toll free at 888-455-2022. You can ask customer service general questions about the lenses, or you can ask for me, and I'm happy to step through some of the more technical details of the product. You can call me directly at 320-257-1182. If I'm not in my office at the time, leave me a voice message and I'll get back to you as soon as I can. We can chat about the lenses and anything else you might have questions about with Eye-Kraft. Or you can email me at jsharp@eyecraft.com. And I'm usually pretty responsive with emails. Again, thank you very much. We're really excited about the Artisan lens, and I am ready for you to be excited about it too. Have a great day.